Volumetric efficiency. What is volumetric efficiency? Volumetric efficiency in internal combustion engine engineering is defined as the ratio of the mass density of the air-fuel mixture thrown into the cylinder at atmospheric pressure to the mass density of the same volume of air in the intake manifold. Ibig sabihin lang ang volumetric efficiency ay mixture ng air at fuel sa isang cylinder na ginagamitan ng atmospheric pressure to the mass density at same volume of air papunta sa intake manifold. Volumetric efficiency in hydraulic pumps. Volumetric efficiency in hydraulic pumps refers to the percentage of actual fluid flow out of the pump compared to the flow out of the pump without leakage. In other words, if the flow out of 100 cc pump is to 92 cc per revolution, then the volumetric efficiency is 92%. The volumetric efficiency will change with the pressure and speed a pump is operated at. Therefore, when comparing volumetric efficiencies, the pressure and speed information must be available. When a single number is given for a volumetric efficiency, it will typically be at the rated pressure and speed. Volumetric efficiency in engines. A piston engine's volumetric efficiency describes its ability to put air into its cylinders. The greater the efficiency percentage, the more completely the engine fills available cylinder volume. For engines of the same displacement, those with better volumetric efficiency develop more power and torque. Unlike other measures of efficiency, such as those per energy usage, volumetric efficiency can and does exceed 100% in some instances. Formula. The formula in getting volumetric efficiency is simply volumetric efficiency is equal to CFM times 3456, which is constant, divided by CID times RPM or speed of the engine. In this formula, CFM is the amount of air, cubic feet per minute, being pumped through the engine. This is not the CFM rating of the carburetor. This can be difficult to measure and requires special testing equipment. How does volumetric efficiency affect performance? Air density changes with temperature and altitude. Therefore, volumetric efficiency can change based on the environment. Hindi lang ginagamit natin ang volumetric efficiency. At hindi lang ito nagbabago sa mga engines pati sa environment natin. At sea level, the air is more dense. This means that there are more air molecules inside the cylinder. In the mountains, the opposite is true. The same engine would operate at a higher volumetric efficiency at sea level than in the mountains. You can improve BE by making it easier for air to flow. This is the idea behind aftermarket intake manifolds, cold air kits, forting and polishing cylinder heads and headers. Pumping more air is also idea behind superchargers, turbos, and nitros. These power adders force more air into the cylinder. When the fuel and ignition system are properly tuned, this can raise volumetric efficiency over 100% and make tons of power. Cylinder volume. Volumetric efficiency is about getting the most possible air into the cylinders. The oxygen in the air is necessary for fuel combustion, and insufficient air means incomplete combustion and less engine power. Pag hindi tama yung air at oxygen na nasa loob ng isang combustion engine, hindi masusunog nito yung air and fuel mixture at magiging mahina ang power ng isang engine. The available volume in the cylinder is the space swept out by the piston as it moves back and forth. Yun, di ba ang cylinder natin ay kung gumalaw ay back and forth, balik. Valves and engine speed. The friction of airflow around an engine valves is a problem for volumetric efficiency. The intake valves often to let air and fuel into the cylinder, but the size of the valve opening limits the speed at which the air moves. Air molecules bump into the valve, slowing the air down. The friction lowers the density of the air contained in the cylinder when the intake valve shuts. Consequently, using volumetric efficiency engine, speed also affects volumetric efficiency. At high speed, less time is available for air to fill the cylinder. Yun, pag binabaan natin ang volumetric efficiency ng isang engine, mas matagal bago mapil ng mapuno ng air ang isang cylinder. Why is it important? Although large engines typically provide more power and better performance, their added weights reduces fuel efficiency and can make a vehicle nose heavy, which affects handling and safety. By improving volumetric efficiency, automotive engineers can wring the most power out of smaller engine design, saving weight, preserving good fuel economy, and handling. This is one example of computing of volumetric efficiency. Let's consider a compression ignition diesel engine with the following parameters. BD is volume is equals to 3.8 liters, NR, which means the speed to pressure 1.5 bar, temperature 40 degrees Celsius, R to 86.9 joule per kilogram Kelvin, speed 1,000 RPM, mass 0.0375 kilogram per second. Step 1. Calculate the intake air density using the equation PA is equals to PA over RA multiplied by temperature. Di substitute lang natin. Ang PA natin is 1.5 times 10 raised to 5 divided by 286.9 times 313.15 is equals to 1.67 kilogram cubic meter. Step 2. Calculate the volumetric efficiency of the engine using the equation NB is equals to mass times speed divided by pressure times volume times speed. NB is equals to 0.0375 multiplied by 2 divided by 1.67 times 3.8 times 10 to the raised to the negative 3 times 16.667 is equals to 0.7991081. Yung nakuha nating sagot, i-multiply lang natin sa 100% para natin makuha yung volumetric efficiency niya, which is 70.91%. Yun lang po. Thank you.